you. Good morning, everyone. Welcome to Worthington University. As Joe mentioned, my name is Patrick Donnelly from Leviton Manufacturing, and this morning we're going to do about a 1.5 hour, depends on how things go, a presentation on Omni-bus lighting, Omni-bus lighting control. You'll see on my screen my PowerPoint. Some slides I'll jump through because I've got a lot of slides in here. We're trying to keep this pretty straightforward. If I need to speak up, just let me know. We're good to go. I'm watching a double-sided screen, if you like. So I'll kick in right away and give you a little overview. But just prior to that, I should mention that I wanted to thank Richard and Richie and all the team here at Worthington University and Worthington Distribution for their time, letting me come into beautiful Tafton, even though it was snowing here yesterday morning, and give this little overview. It's, as I say, about a 1 hour presentation, and if there are any questions that Joe mentioned, put your hand up, and we'll see if we can answer them on the way through. If there's any sort of hiccups with the video, with my live demo here, we'll kind of work through that as the morning progresses. So with that, just move on. So some of my slides are a little outdated, but what I wanted to do was give you a quick overview on what we're going to do. We're going to go through a product information right now. We're going to give a breakdown on components. That's the piece that I'm going to kind of focus on a bit. My background is electrical and electrical engineering. I'm a master electrician by trade, so I like to dig into some of the components just to make sure you understand how they install, where they would be located, and applications you might use them for. We're not going to drill down this morning into a lot of programming. We'll just overview it, and that's about it. So with that, so some quick product overview, if you like, or product information. What is Omni-bus lighting controls? Omni-bus lighting control system is a 110, 120 volt system. Initially, this product lineup was developed and implemented, if you like, in the foreign market, overseas, in the South African market and in the Australian market. And then Leviton and a part of the old company, HAI, brought it into here, the US, in approximately 2012. So it is a 110, 120 volt, 220, 240 volt, 50, 60 hertz system. We can control basically everything. I'll drill into that a little bit later in terms of lighting products. And you'll see up on the screen I have CFL, LED, incandescent, ELV, which is commonly known as electronic low voltage, halogen, pumps, fans, shutters. We can drill down into quite an array of different products that we can control. We have the slide is a little outdated. We have one new module and a number of cabinets, special enclosures where we'll mount all these devices, all the different modules that you see on screen. Everything is ETL and UL listed, and you'll kind of see that a little bit later. Joel's going to help me modulate between the web and my PowerPoint presentation. We'll go into that a little later. So just moving forward, Omni-bus features and benefits. Very simple and easy to install. The products are all DIN rail mounted in the cabinets. We'll go over that a little later. Everything's on a bus, a Cat 5 or a Cat 6 UTP twisted pair network. And the software is available from our web portal. We might get to have a look at that a little bit later on. It's a free download. Competing systems require home. This product lineup fits right into new installations or some retrofit installations, but generally speaking, new installations. And I'll speak to a number of projects that I'm fairly familiar with later on. But generally speaking, it's in that larger home, larger residential application or small commercial application. It's fairly simple to set up. It's a multi-button programmable wired and wireless wall switches. So we have the opportunity, like I mentioned, to do retrofit. And then in new installations, we install wired wall stations and keypads, and I've got another one that I'll show a little later on. It's eco-friendly. We can, in certain applications, in certain commercial applications, you can save a lot of home run or copper cabling based on how you locate and design the system. Design is very important, and design at the front end of a project is very important. So I'll emphasize that as we go through the presentation this morning. We do also have wireless components, as you see in the last bullet, for retrofit. So we'll skip forward to the next slide. How does Omni-bus work? And you'll see on my PowerPoint presentation that we kind of laid it out in a diagram for you in a modular system where you see the bus looping, and you're not going to be able to see this, but this actually helps me to explain it to you. From one of our 3-way or 8-way splitters, it's going to loop out and in and out and in and out of each module, and then we'll go over how you terminate in a few moments. And of course, this is a standalone system, or you can interact it or integrate it with other controls. All modules in an Omni-bus system are connected, as I mentioned, over a UTP bus. Each DIN rail mounted device is supplied with a pre-wired jumper cable, little small Cat5 or Cat6 jumper, and it's DIN rail mountable. As I said, the power is fed through. Each wireless or wired switch connects to a DIN rail module, and that, what I mean by that is wired or wireless push button switches. We have two devices here on the table that I'm showing. One is an elegant 2-button controller, and this is an actual customizable, most often used in the European market, but it's a customizable 6-button wall switch. This one is wired. This one here is not wired. This is wireless. So there are diagnostic LEDs on all the devices to help troubleshoot in installation. It's actually very handy for identifying what devices are on and off. Omni-bus components assure properly terminated data cable for high-speed data bus. So no jumpers to set. There's no switches to toggle. We'll go over that a little later on. Move on to the next slide. How is Omni-bus flexible? It is a network that can be star or hub and spoke, daisy chain, or a combination of these. And an application that I'll mention maybe a couple of times today would be one that I had been involved in, a small gym, a USA type gym, where the actual distribution panels, the wired modules, were located throughout the building and then just connected on a bus. And that's kind of what this speaks to when we mention the very first bullet. Omni-bus networks can be star, hub and spoke, daisy chain, or a combination of all these. And that's kind of what they did on that project over in Michigan. Omni-bus includes low-cost splitters and T-connectors for ease of installation and expandability. And it's open architecture, so we can integrate with third-party wall stations, which is kind of like what this looks like here, the European-style device. Omni-bus uses standalone or can integrate with other automation systems. Primarily, we're going to speak about Leviton Omni, but we'll touch on that a little later on. And this is a kind of a listing of all the devices that we speak to in an Omni-bus system. As you might have seen in the very first slide, it noted about 29 components in the full product lineup. There's actually a few more than that. There's a new module that we introduced about 6 or 8 months ago in 2017. It is our new 4-channel 0 to 10 dimmable module. I'll show you that in the next slide. And then all these devices that you see here. Primarily, the devices that we're going to focus on today will be the power supply, the 2 different dimmers, the switch module, the relay module, the transceiver, this device here, which puts everything on a network, the scene controller, and then some of the other devices such as the 3-way splitter, 8-way splitter, jumpers, termination, and so forth, the power supply, as I mentioned. There are a couple other devices in the listing here that, generally speaking, we don't come across, or we don't touch on too often here in the US. They're primarily geared towards the European market and the overseas market, I should say, global market. And we see the Dali Gateway, and there's one or two other products in there, but we'll pass over those for now. Next item, I actually inserted the slide this morning just to make sure we touched on it. This is the new 0 to 10 DIN rail mountable dimmer module from Omni-bus. It was introduced about maybe 6 or 8 months ago. It has 2 inputs and 4 outputs, 4 channels as such. It's a nice device. You're going to see this used more often in commercial, although we do see 0 to 10 lighting systems rolling over, or I shouldn't say rolling over, I should say the cost level of some of these fixtures is now coming down. So you see 0 to 10 devices in residential applications, especially in the larger projects. And this is just a quick cut sheet on a quick overview of the specs. I just pulled off the web this morning. 2 isolated input channels, as I mentioned, and 4 output channels. And we'll flip over later on. I'll ask Joe to click onto the Leviton Omni-bus web portal, and we'll take a look at some of these items. So what interfaces work with the Omni-bus family? This is a better photograph or display, if you like, of what I was showing earlier on camera. 1-button hardwired switches, and then the wireless switches, as well as our little key fobs, the little transmitter wireless key fob, ideal for keychains and so forth. So we have them in 1-button, 2-button, 3-button, 6-button, and then the key fob is 6-channel and 16-channel. Very, very simple. What I can do with a wireless button, let me see if I can press them. You might hear it coming on here. I turned on a fan. I can toggle the fan off. I can do the exact same thing with one of our station buttons, and it's difficult to see here, but I could turn everything on, turn everything off, or I could do it with one of these, or I could do it with a, let me see if I can do this correctly, a lighting system here. We're turning on a light, turning on another load. It's hard to see and with the camera, and then turning them off. We're really toggling them with the wireless key fob. Moving on, can I connect other wall stations with other customizable prefabricated wall stations? You see this more often in the European market, which I had a little bit of experience in. And this device on screen right now is a 6-channel universal switch interface module. So I'm not going to delve into it too deep, but we could go ahead and go to a panel making manufacturer, or a switch manufacturer, or a metal fabrication shop, and have customizable plates made up for toggle switches, for momentary toggle switches, and then utilizing this device here, this 6-channel universal interface module, we could have those buttons on one of these customizable faceplate controller device or toggler device or whatever. More options for a very nice universal system. What does the scene control look like? What does the scene controller do? What does the scene controller look like? I have one of our devices, one of our scene controllers on a bus here. We tied it into my demonstration case. I left it outside, thanks to Richie this morning, just to be able to show you exactly what it looks like. Very powerful device. The Omni-bus scene controller enables lighting scenes or moods to be configured for each Omni-bus load. And then those loads and that scene can be triggered from any one of these devices within the network, within the facility. We can have up to 32 different scenes. They can be configured, defined, controlled, up to 256 Omni-bus load control modules. And what I mean by that would be either a switch or a dimmer or a relay and so forth. Each scene can be triggered from up to 8 different Omni-bus input devices, as these are input devices. E.g., buttons on a wired wall station or wireless station. So it's fairly straightforward, very simple. You're really and truly in an Omni-bus system. You'll do that in the software. You're mapping push of a button on one of these devices, whether it's a wall station, wired, wireless, or key fob, you're mapping when I press this button, turn on a certain load, or trigger a certain scene. Very, very simple. And then you can predefine what you want to do with that button. Do you want to toggle the button? Do you want to turn it on? Do you want to double tap it? That's where the software becomes the driving force behind how this simple system becomes very elegant. So, component breakdown, and this is kind of where we're going to go most of the morning. We'll flip over as I get to the end of this, Joel. We'll probably flip over to the website and then the software just to show the folks online. Key mandatory components in every install, and I mentioned another install on one of these newer modular gymnastics, like a gym for a community. We had, in that scenario, we had multiple cabinets located throughout the building, and in each of those cabinets were mandatory power components. The Omni-bus power supply, a power supply interface, and some jumpers, because they actually had some of the modules co-located throughout the building, so it made it easy for the electrician to do to actually install the wiring. So you have to understand that an Omni-bus system does need, and in every system does need, a power supply, and then that power supply ties into the power supply interface module, and then all the other modules in the bus, if you like, the Cat5, Cat6 bus, tie into that. And then we have jumper plugs and a termination plug in every cabinet if you had multiple cabinets throughout the building. So moving forward again, we're going to talk about the first component, the power supply. It's mandatory. It's a 24-volt DC, 2.5 amps power supply. Excuse me, I get tongue-tied after speaking for a little bit. Provides power to Omni-bus networks. That's when we kind of mention the Omni-bus network, we're really and truly meaning the actual Cat5 UTP cabling throughout the building. Always used as a pair with the power. So this is kind of what I mentioned in the last slide, with the power supply interface. And you'll see the both part numbers. I'm not going to start rattling off part numbers this morning. More than one power supply and power supply interface combination systems can be used if the total network current consumption exceeds 2 amps. That's key to remember here, folks. Those of you who are online with me this morning, it's key to remember. And that 2.5 amps also relates to distance, cabling distance between cabinets. So keep that in mind. One of the key items, one of the really nice pieces about being here at Worthington is that the guys here, the folks here, have a really very, very adept technical support team that can help with design, layout, part supplies, bill of materials, all that sort of stuff. So keep that in mind if you have any questions on it, especially on this component here. Power consumption data, 24 volts once again, 2 amps maximum draw, and then there's the lengths of this is the lengths of the cabling within this. Here's what it looks like. Power supply. We've got a couple of slides that we're going to just give you a little run through on. You'll notice in my presentation, this is the presentation that was given overseas. It's a 220, 240 volt. The system is designed for it to work either way. 110, 120 volts here in the US, 220, 240 volts in the British Isles and in other parts of the globe. That's the power item on the list is the interface module used to detect low voltage, overloading, and select cabling errors on the network. This device does a lot of work. Not that we're going to drill down too much into it, but that is a quick overview of what that does. It's mandatory. That device and the power supply have to be on every system. More than one power supply and power supply interface combinations can be used in a system. Total network current, once again, is 2 amps, okay? And then keep in mind that whole concept of the length of the bus. Power supply interface module, you're getting a look at what it looks like. Is the bus cabling down below here, Cat5 UTP system. Cat 5 or Cat 6. It's not mandatory to be Category 6. You'll notice once again it does mention 220 volts, but 220, 120 works with both systems. Mandatory components that we also need, and this is key, and this is kind of what I did this morning when we added in our little scene controller. Very difficult to see right now, but you'll see it on the screen. The scene controller has a jumper. There's two ports on the module itself. We'll see if Joel can zoom in. Hopefully you won't. Okay, so you'll see on that module there's a Cat 5 cable and then a jumper. Oops, sorry, I'm blind. A jumper here. Thank you, Joel. We'll zoom back out to the presentation. Those jumpers come in a pack of 10. You will, oops, beg your pardon, clicked the wrong button. You will actually use them on a project. You'll be surprised. Another quick tip here. I've seen this Omni-bus system retrofitted into older Cat 5 based systems that are out here in the US especially, where a customized keypad at a wall station had a cable in the wall. That's how the electrician started the conversation with me. We've got one Cat 5 cable, so what we did there was we put a jumper in one side and used the Omni-bus system and replaced it with our keypad or wall station. So keep that in mind. You will need you may not think you'll use all of these jumpers, but you will. All open ends. Let me run through this real quick. All open ends are open connectors, usually the last device on a system. Very similar to what we did here today. The last device on the loop has to have a jumper. No open ends should be left. That's the best way to put that. Then at the I'm not going to drill into this system. This is actually a template that I have in front of my system, which is mounted in DIN rail in behind my case here. Right in behind there, you will, if we opened it up right now, you would see this device here. So not to be confused with the device I showed you a few minutes ago, this is a termination plug, okay? This is a termination plug at the very end of the system, usually back at the cabinet. That's usually back at your load center, if you like, or where all the Omni-bus equipment is mounted in a DIN rail cabinet. Each network must contain, and that's key, must contain one of these. And the part number is on the screen. I'll stop for a second or two. Any questions, Joe? Nothing that we have to. I think we're good. I see you typing, yeah. I think everything's good right now. Powering the Omni-bus system. You'll see. Hopefully the screen is pretty clear for you folks online. It's a little blurry for me as I look at the screen here, but I think it should be okay. It's looking good on your presentation there, Joe. Okay. The power supply must be installed at the point where most devices are located to avoid excessive voltage drops. This is kind of going back to what I mentioned before, where you might have decentralized some of your loads or some of your modules in cabinets scattered throughout the building. It makes it easy for the electrician, but you do have to take into consideration the last point that I just mentioned, voltage drop. If that length between cabinet A in one mechanical room for example, that large gym, cabinet A is in one mechanical room and cabinet B is in another mechanical room at the far end of the building, we may need to have a supplemental power supply and an interface in that cabinet. Optional components. This is, I haven't come across this first item. I haven't come across this as an option. And generally speaking, most of the projects that I've been involved with would have the interface translator built on board, which is what we have in this little system here, this demo here. Today we have an interface translator board built on board that comes with USB interconnection. It comes with an RS-232 interconnection, and then it comes with what we've connected to our network here at Worthington, a Cat 5 jumper, Cat 5 connection. But if it were a scenario where the customer said, we're not going to be on a network, we're not going to connect to it, you, Mr. Electrician, as the contractor, are going to come here and service the system on a regular basis, then you would need for sure an RF transceiver or a USB interface, programming interface, one or the other. Most likely the USB device. The other items on the list here, there's one item, as I mentioned earlier, that is not necessary in the I shouldn't say not necessary. I beg your pardon. What I should say, I haven't seen it used too often here in the US. It's primarily a DALI interface for European and global markets, not so much for over here. And then you will need in most systems 3-way splitters and 8-way splitters. And of course, the scene controller is a key component. You'll always need a scene controller because your customer most likely will want to have scenes throughout the home or the restaurant or the bar or the house of worship, or in my case, I just mentioned that big USA gym. Let me back up one slide real quick. And you kind of get an idea what's going on here with that device here. That's a splitter. That's the 8-way splitter. Let me back up once again. So that shows you how we split off to other cabinets or other components in a larger cabinet or whatever the case may be. This is the RF transceiver, okay? Used with Omni-bus wireless wall stations and wall station interfaces, including the part numbers that I mentioned here, as well as the key fobs. This is a 2-button wall station that I'm showing here, and this is the key fob. We'll see little photos of these a little later on. 30-meter range, about 100-foot range, so don't go too far with these. Works with up to 56 link devices. As I mentioned, 30 meters, 98 feet. RF receiver built into the device, okay? Built into the next device that I'm going to talk about, and I'll back up one more. This is the device that I had mentioned earlier. It also has, I mentioned, USB, RS-232, Cat5, and I failed to mention the actual wireless component, which is what this slide is mentioning right now. It does also have, so that device, it's probably the most expensive device on the product lineup, but it's one that I've seen used in most designs. Okay, power consumption for this is 15 to 24 volts, 21 milliamps in standby, 50 milliamps max draw on when it's in the on position, when it's working. Best way to interact with it. And this is the transceiver on its own, okay? And you'll see the connectivity here, and you'll see it is required to have an antenna, which is only common sense. This is the USB device. This is something you, as a contractor, I believe, would carry in your tool belt if you were going to service multiple Omni-bus systems. You would have this in your tool belt, pull into the job site, get out your laptop, fire up the software, and now you can interface with the system very simple, very easy. Not going to spend too much time. This is the device that I believe most projects will have designed in. And we at Leviton, as well as I mentioned, the fact that we have great support here with our friends at Worthington, we also have design. I'm not going to drill into it too much. You folks can ask questions a little later, but we do have a design assist team that you can email, connect with me, and I'll connect with you with those folks, and they'll actually put a bill of materials and design diagrams together for you if you have a large project. Most projects, I will tell you, will have this device. It acts as a gateway into the system. As I mentioned, you might be able to see it. It's not really easy to see. In the next slide, you'll see it a little better. That's the RS-232 connectivity component, DB9, what we call it DB9. You'll see the pinout in a few seconds in a line diagram. Connects Omni-bus lighting and network lighting control system, the network, to a Leviton Omni or any other automation control system. As I mentioned, it has RS-232, it has the USB port, it has the network connectivity, and it has the wireless piece built on board. A very nice unit. I always design it into each system. So here's the top and the bottom line diagrams. Top second here, there you'll see the actual RS-232. If I pull down my template here right now, you could see the network cable plugged in. Myself and Richie did that a little earlier. There's the network connectivity cable there, Cat5 LAN connector. Then over on the other side here, you'll see the USB connection and the antenna. So it's fairly straightforward. I will tell you, every job should get one of these. It's going to make life easier for you down the road. The Dali gateway, I'm not going to touch on, just give you an idea what it looks like. Primarily used overseas. If we have questions on this later, we can jump into it a little deeper, or we can go offline. Three-way splitter, ideal component. Nearly always specify one of these into most jobs. Now you could, this could be the primary splitter that splits up, as I mentioned in my application. Mechanical room number A on the east wing of the building gets tied into two other mechanical rooms in different parts, or maybe in different floors of the building, and you could use a three-way splitter to tie in the bus network in this situation. Let's see. The 8-way splitter looks a little different. There's a lot more components built on board. You saw that in the very beginning of my presentation. I kind of showed you a line diagram. The connectivity is underneath. I believe the next slide shows that. Once again, same idea. Connectivity up top, down bottom. And this is how you would break out, if you like, to other cabinets or other DIN rail panels mounted in a main mechanical room. But a mechanical room might have 6 or 7 cabinets in it, based on how big the projects are. Scene controller. This is the most powerful piece in the system, besides the device that gets you on the network. This module enables lighting scenes or moods to be configured without use of any other control system. So it's this is where Omni-bus becomes a standalone system. I can press a button, excuse me, and configure a scene. And now in my little demo here, you just see one light going on and off. I have a toggle on one little button, but that could be a multitude of different lights. It could be a fan. It could be a fan. I'm not sure if you can hear that. It could be a number of different devices throughout the building, creating scenes for your customer. I'll turn this off. Turn off the toggle on the lighting. So it's a very powerful device. Up to 32 scenes can be defined within this one little module. Each scene can be triggered by up to 8 different buttons or devices in the system. And up to 256 maximum load control modules, dimmers, power switches, relay modules, and so forth. You see the consumption down below. And then you could have multiple in a system. You could have multiple scene controllers in a system. It's a very, very powerful device. This is kind of what you see going on here is scene control as well as automation tied into one of our Omni controllers. That's an Omni Pro 2. Multiple Omnibus scene controllers can be added to enable additional scenes, and then to take it to the next level, now you could integrate it with an Omnibus system. So the meat and potatoes of the system, the Omnibus modules. And a module clicks, and we didn't really go into this in a big way, but it clicks on. This is, if you can imagine this being my DIN rail, the module actually mounts on the DIN rail from top to bottom, and right behind at the bottom end there's a little pull pin. You pull the pin, snaps in place, and it's good to go. That's how you actually mount the devices in the system. In my little demonstration module here, you'll see that I have a power. We've got the interface connection pieces down below, and then the power modules and the actual dimmers and switches and a relay bank here on top. And this is built into it's not really and truly a cabinet. It's a traveling demonstration case. So we have a Omnibus Universal Dimmer, which is my favorite component. We have a regular dimmer. We have a power switch, and then we have a 4-channel relay, and that's exactly what you're seeing on top here that I just mentioned. This dimmer here is rated for 400 watts, and the bottom, the next item on the list, is rated for 900 watts, and then this device here is rated for 15 amps. We'll drill into the system in a few seconds. Joel is actually giving you a close-up, which is pretty good. I'm glad you did that. I can actually trigger. We'll just do that real quick. You'll see some of these devices. they have an indicating light on each one of them. They also have an override on each one and a manual trigger. So if I turn on one of my loads, which is after going on the system in here, and you'll see that the actual module itself changed. If I toggle it off, you'll see the light went up it's actually coming up pretty well, Joe, on the video, which is good. This is the next lighting load I have, and you'll see the module, it's on a different module, and it goes on and off. And then I have a couple others. This is the fan module, which is really turning on the switch, I believe. This is not my demonstration case. I had it shipped in. And then we have a couple of other little scenes set up in here with the other buttons, where it brings on one dimmer to a certain, one lighting load, dimmer module to a certain level, and the fan on. So we'll turn that off right now. I have not configured this device. We just installed that this morning just to show you what it looks like. That is a full button US wall switch. So Omni-bus dimmers, universal dimmer, power switch, and a relay. Varies based on the number of loads. So this is at this point in time, it's vital for you all to understand that design is crucial. Floor plans, wiring diagrams, lighting, load schedules, all this sort of data is vital, especially if you're making a phone call in to the tech support team here at Worthington, or you're connecting with one of our team, or you're involved with the design assist. They're going to need that information. So you need to have a floor plan. You need to have some sort of an expectation from your customer of what type of lighting control they want within the building. And then we move on to the actual devices necessary where you can figure out what you're going to need. So this is the -1 dimmer module, and that's how we talk about these modules. This is the 400-watt dimmer that I mentioned. And of course, once again, you're seeing some of my slides that show EU, if you like, voltages. This is also rated for 120 volts, 120 volts, 110, 120 volts here in the US. It can control incandescent loads. This is where it's real important to understand what's going on, folks. So how these modules work, because the world of lighting as we know it today, and I've been doing this since 1972 about, when I began my apprenticeship, the world of lighting has actually changed completely. So you need to really drill down and understand what your customer is installing, what your customer expects, and the type of lighting loads that you're working with. This dimmer module works with incandescent, halogen, and what we typically refer to here in the US as ELV, low voltage electronic devices, trailing edge dimming. Okay, it stores up to 32 links. In other words, we can control it from 32 different links. It features adjustable min-max lighting levels, adjustable soft on and off rate. This is where you see the power of the Omni-bus system. Adjustable soft on and off, configurable dimming curves with min and max offsets according to the type of load. So with the software and your load tied in, you can actually see how the dimming module works and visually look at your loads on site when you're tweaking the system, if you like, after the system's up and running, or commissioning it. And once again, I can't emphasize it enough. Design, layout, all this sort of legwork needs to be done up front prior to offering your customer one of these systems, because you need to know some of this stuff. So there's a status LED on the actual device itself, which flashes. And then this is the power consumption. Once again, it's on the bus, that Cat5 bus that goes in and out on the bottom of the module. That consumes about 16 milliamps when it's in standby, and 20 when she's running. It's running on 15 to 24 volts DC power supply. That's where our power supply in the main bus, and I have it down at the bottom here in my system. That's where that comes in. This is what it looks like, as I kind of mentioned earlier on, and I realize you can't see I'm using a pointer, you can't see it, but this is where you see on the bottom section of the actual dimming module, the network, the bus network, the cabling, that Cat5 UTP cabling that I mentioned. This is that push push button that I also mentioned, manual push button that you can actually tie into. You can do it locally on the actual device, and then you can have an external push button. Thank you, Joel, for to actually what you might call an override. What we might in the controls world think of on a control panel as an manual override. And then here up top you see the load line in 120, 140, 110, 120 volt US current, and then the load is on the next set of terminals on the way over. The terminals are rather large, which is ideal. You know, it's not necessary overseas as the gauge wiring gauge in EU lighting loads and global loads outside of the US is much smaller gauge wiring than we have here in the US. But typically here it's going to be 14 gauge, and those connections are pretty good. I will also emphasize from a design perspective, in these changing times where most of our, let me back up real quick, where most of what we see in the out there in the world is LED loads. It's very important to understand the load that you're getting into, and then also how that load works. So just keep that in mind. And I flicked through too quickly. I should have went the other way. So as I mentioned, it's very important to understand what you're playing around with, what type of what the design of the system is, and generally speaking, I'm going to tell you folks, most customers are going to run into LED nowadays. Incandescent is on its way out. Halogen we don't see so much anymore. Definitely CFL, you don't see too much of that anymore, but you do see a low voltage electronic LED controls or lighting. So that's our first dimmer module, and that is a 400 watt device. This is the one that I see used most often. This is the Dash 2. That's how we kind of talk about it. This is 10 watts to 900 watts. So it's got a wider range, a higher range is the best way to touch on it. It also can handle incandescent, halogen, low voltage electronic, transformers, low voltage magnetic transformers, and then there's your wattages. And of course, you do see that 240 volt, 230 volt nomenclature up there. This device is rated to be UL listed for here in the US, so you're all set to go. You do need to understand that, and you'll see it in the next slide. There's depending on what type of lighting load you're working with, there is a jumper to configure. So be aware of that. The memory capacity, it can memorize up to 32 linked devices. Those are input devices. Features adjustable, once again, similar to the last module, but just has the ability to control, has what we would like to refer to as universal. It has the ability to control a lot more types of lighting loads. So it does feature the same features as the last module. Adjustable soft on and off rate, configurable dimming curve, min max, offsets, and then basically you're going to play around with this when you're commissioning the system to see how your lighting load acts. It has status LED, and it also has the override. We'll show you that in the next slide also. Any questions as I touch base here? No? Everything good, Joel? So far, so good? Okay. When we get to the end, I think when we get to the end of these, this little module section, we'll flip over. I'll just give you a preemptive. We'll flip over to the Leviton Omni-bus web portal just to show the folks some of the items online. This way, it'll be a resource to you. You can also drill down into Worthington. They have a boatload of really, really good material on their web portal. So this is a line diagram, if you like, of the device. Once again, you see on the top section, you'll see we have 110, 120 volt. We put it in there for you in this little slide. You can see the load. That's the neutrals are actually connected internally, and then you'll see the override button on the actual front of the device, and then the actual wired override button, and then the bus cabling. And the mode selection. This is the item that I kind of mentioned earlier on here when I said selectable jumper. You need to be aware of the type of lighting load. Is it trailing edge? Is it leading edge? forward facing, reverse phase. There's many different ways to refer to this. It's the best wording I can give you. If you don't really understand what we're talking about here, this is where the guys here at Worthington can actually give you. They can actually help you when you give them some more data on the products that the lighting products that the lighting designer has specified into this project. So that's the universal module, my favorite. The next item on the list is a simple old-fashioned switch. This is what we refer to as -1 power switch, resistive, incandescent, halogen. It's pretty, I'm not going to say completely universal, but pretty universal. It can handle ballasts, which is typical fluorescent lighting loads. And all we're doing with a switch, which a lot of you folks online will already know, you're turning something on, you're turning something off, or you're toggling it on and off. It has the ability to do low voltage electronic and low voltage magnetic transformers. So this is a nice little device. Ideal, I see this device used a lot for under kitchen cabinet lighting, which is primarily, or generally, I shouldn't say it primarily, but generally speaking, it's what I see in the trade nowadays is this tape lighting that you see that mounts very simple and easily underneath cabinets. And then that can be, depending on the product and the brand name, the manufacturer, that can be ELV or it can be magnetic, MLV. So keep that in mind. DC resistive 10 amp at 30 volts, and we can handle 2 30-volt motors, or generally speaking, anything up to 1 horse in the U.S. market. We have the ability to have memory of 24 linked devices. It has the same items online as I mentioned in the last 2 devices. You'll see that in the next slide. Override button on the front, power in, phase, as we mentioned overseas, the phase and neutral coming in, or the L1 and neutral coming in, and then your load, and then the data bus down below. Next item on the list, 4-channel relay module. Ideal for pumps operating other lighting controls. Maybe you want to operate the whole set of parking lot lights, and you use one of my relays in here to trigger a lighting contactor, a large 6-pole lighting contactor, something like that. So it can control up to 4 general purpose relays, and there they are, 1, 2, 3, 4. 2 amps at 230 volts, 2 amps at 110 volts, 2 amps at 24 volts DC. That's pretty cool. Or general purpose low voltage switching. So it's a very, very, very neat device. With relays in the world of automation, you can practically do anything with a relay. It's what we've been using forever and ever to integrate other components in in a home or in an automated home. This is what our little line diagram looks like. Did we lose any folks from our presentation? I don't think we did. I think we're all still online. So this is a line diagram. I'm not going to drill down too much into it. There is a segment here where we could trigger, for example, a gate or a garage door. You can use that for lots of different applications. And then wall stations. I'm not going to go spend too much time on these stations, because you can have a combination of a number of these in a system. This would be where you definitely get together with the folks at Worthington to go over the design and then figure out from your layout and the design of the project where the customer needs a user interface. And then the next level after that would be, if you wanted to do automation, tie it into one of the Omni panels, and then you would get remote control via an app on your phone. So this is a 1 button. We're going to flash through these pretty quickly. I'm coming up on a 1-hour segment, pretty close by. This is a 1 button wireless wall station. Very simple and straightforward. You can see what's going on here. 2 button. This is an RF transceiver. Okay. So we can tie this into the system, and it connects into this device down here on my demo case here. That's what's going on when I actually press one of my buttons here and turn on a lighting load. This device here receives it, talks to the dimming module or the lighting module, turn it off. We have a 3 button. same scenario. And then the key fobs, fairly straightforward. 6-channel available, wireless RF transmitter, and it's built in to this device here, so that's what it communicates with. Controls dimmers, power switches, relays, or any input to a Leviton automation controller. About 30 meters. Don't go crazy with this little device. This is not going to reach out the very end of the driveway here at the Taft University. It's going to go up to about 9800 feet, and that's about it. 16-channel device, and then wired. Here we get into the wired stations. We have a 1-button, 2-button, 3-button. We also have this device, which is not on my list, but it is new. It's a 4-button device from Leviton. This is typical of the U.S. standard wall box, your standard 119 box. This is how those actually physically wire. That's actually what you're looking at on the back of this device here. If I was to, I don't know whether you can see it very well, but I'm putting my little LED light on here. This is the station. These are the Cat5 jumping cables here, in and out. If this was a standard, just one cable scenario, I mentioned the retrofit earlier. One Cat5 cable in, terminate with the plug on there, or J45, and then one of those termination blocks goes into the other port. One item that I will, and I didn't touch on, but I should do, it's vital, folks, that you understand UTP wiring and where your blue, orange, green, and brown cabling. It's fundamental. The old-fashioned Cat5 fundamentals, the standards here in the U.S. So your blues and browns and oranges and greens have to go in a certain segment, a certain sequence inside that jack. I highly recommend you learn how to terminate those, and then I highly recommend that you purchase a testing tool. There's all sorts of wire mappers out there, so keep that in the back of your mind. And the folks here at Worthington have that in their catalog. Next item on the list is my 3-button wall station. I think I skipped through. I did. These are the white devices. This is classic white. And then these are the stainless. This is actually a good rendering of what I'm holding up here in my hand. Okay, and you see the back of it as well. So and with the software, we can configure that to be a toggle or a push to go on, or a push to go on for a certain time, and so forth. I'm not going to drill down too much into it. Typically, I have to say, most of my experience and interaction with contractors using this type of product, this particular device, has not really been here in the U.S. 1 or 2 projects, but generally speaking, overseas in the EU market. And then this is our 6-button wall station. I do not have one of these here. And 6-button. This is actually the device that I'm holding up in my hand right now. And then when we drill down and start to do our own 6-channel switch interface, we're starting to do our own type of controls where we want to build our own keypad, or the customer says, I want my own special keypad engraved with certain nomenclature and whatnot. This is the device you can use for practically any other of those scenarios that I mentioned. This accommodates nearly any shape or style of momentary contact. It is a universal device. So we can tie in contact switch, connect up to 6 third-party momentary type switches, operate as if, just exactly as if it was a wall station. Utilize multiple 6-channel universal switch interfaces in one project, and then you can make it an on or an off, a dim, a brighten. You can make it do whatever you want to do. Not going to drill down too much, and don't see that used that often, because typically you're getting into manufacturing your own plates or customizing your own plates, and that can be costly. This is kind of this is how you actually physically wire it. You will need these cable assemblies, and there's a little jumper on the end of each of these pigtails, and that's what you're doing. Not going to go there too much. This is a line diagram. We're going to skip through some of this, and we're going to skip through that, and we're going to come to basically an overview of what a system could look like. I recently visited a large restaurant in the New Jersey area, and this is exactly what they had. They had 3 three different panels, enclosures, mounted in the mechanical room, right next to another enclosure with all the interface modules and the Omni controller on board. That's an Omni Pro 2 there. So you'll see we note in the little caption to the right of the line diagram, network cabling is all Cat5. Connections, all cable ends must be terminated. This is actually a cut sheet that's on our web portal. We need a termination plug. We need jumpers. We definitely need splitters. You probably see a splitter right here, and then you see an 8-way splitter right here. Okay, you see the interface via a USB device to a computer. They're kind of, with our line diagram, we're kind of showing you a little bit of everything that you could do. More than likely, you're probably not going to use this in this scenario. You're going to tie to the network over a network cable, because that device there puts it on your local area network. Maximum cable length, the total cable length on a single Omnibus network may not exceed, and this is key, folks, about 3,280 feet, 1,000 meters. We're here in the U.S., so we're going to stick with the old British nomenclature, feet and inches. And maximum number of devices, 256. So those two items are two very, very key factors that you've got to keep in mind when you do a system like this. Let's see what's in the next. Product sales information. We're going to flip over just real quick to, if you wouldn't mind, just to connect over to the Leviton markets. And now, what I'd like to do real quick, if you wouldn't mind, Joel, just click on the DIN rail. I wanted to just show you folks what the cabinets look like really quickly. Slow internet. Slow internet. Sorry, folks. I'm not sure if I'm still on screen, but here we come. This is what the cabinets look like. We have 3 models, and we'll just stick with one model right now. This is the intermediate model. We have a small model, which is really just one DIN rail, one rail. We have an intermediate model, which is this device here that you see on screen, three rails, and you can have 5 modules. The best way for me to explain it to you would be 5 dimmer modules. Not so much the other module, but 5 dimmer modules. Leave some space. You'll always end up needing it, so don't compromise on space here. And the next module up is the 5 module cabinet. So you could have a combination on any project. You could have maybe a couple of 5 DIN rail modules one in the mechanical room, and maybe scattered through the building. Maybe the three rail cabinet or the 1 rail cabinet. And you want to click back, just head back, Joe, yeah. And we'll hit the modules. And in here you can see, perfect. It might just take a few seconds to come up. We'll see all the different modules that we have in here. And the primary modules that you're going to use in the system will be the 400-watt dimmer, the 900-watt dimmer, the 15-amp switch, and the scene module. And here you see some of the devices. There's the power supply. There's some terminators. This is another power supply interface module. The scene controller. You're going to need a scene controller on every system. And then if we just scroll down a little bit, you'll see this is an 8-way splitter. This is a 3-way splitter. And this is the Dali gateway. We're really not going to use that too often. This is a pack of those jumpers. And here's where we get into the devices you use in the US. I'm going to suggest that you always put one of these in your system, because your standard bill of materials in most of these projects will pretty much be the same on most jobs. Just the quantity will change. So you'll need a DIN rail translator. You'll definitely need this device if you're doing some wireless. It really depends. This could be an option. You'll definitely need relays, because you're going to trigger gates, you're going to trigger fans, you're going to trigger devices that you need a relay for. And then here's the powerhouses: power switch, dimmer, and a dimmer. This is the dash 1, which is the 400 watter. This is the dash 2, and then this is the 15 ampere. And I think I don't know if there's anything else down below. And then just as a segue into this, Joel, if you would just go back to a dimmer. Just scroll down. No, scroll back to yeah, and click on. Let's click on the -2. Perfect. If we click in there, when we get into this system or into the meat and potatoes on this, you can see the features and benefits and what it does, and it gives you a little spec on it, and you can read more. And then if you scroll down, you can actually go into support and downloads. And when you get here, that's where you go. It's a little buried, unfortunately, but that's where you go get the software. It's we're at a new version of software right now, and so it's version 1.1.6, and that's really to accommodate the latest and greatest 0 to 10 dimmer in the system. So were you going any further there? No. So if you could just back out of here and maybe just bring up the software real quick, if you can. Yeah, perfect. And just go offline for a second. We'll connect in a few seconds. Yeah, drill down. Joel this morning is my Vanna White, so he's operating the mouse. So it's a little difficult. It's not difficult, but it's a little different for me. Usually I'm in front of a classroom with a mouse right in front of me. No, but I'm good. No, you can manage it. You're fine. If you just wanted to do real quick, do an all bus device drop down, and then let's do all. Let's start with all bus devices. What the heck? And add the device, and then the drop down list. Here's where you get. This is. And now I'm not really online here, but what I wanted to show you was the devices that will control your system. And this is where you see at the very end here. This is new for me as of last year. This is the latest and greatest relay control for 0 to 10. So it's actually a pretty nice little device, and we can tag over to that a little later on. But what I did want to show you was just all the different systems within all the different products within the system. See the transceiver. There's the transceiver in there. You'll see the button stations. You'll see the 300-watt switch. You'll see the 400-watt switch, and you'll see the 900-watt switch. But that's good. You can get out of there, Joel. And just go online. Just show the folks how to. We're going to go online, and she's after going online. Just took a little second or two for it to go TCP/IP. Initially, we've got it all set up here for ease of integration and ease of time. Basically, we didn't want to spend a lot of time, but generally speaking, folks, you're actually going to connect for the very first time using a USB cable to the device, and then once you're connected via USB, we're online with TCP/IP. But once you're connected, you hit the list device button, and the system actually just talks right away. It's kind of like for all the world, and the way I explain to contractors, it's for all the world, like pairing your headset of your phone to the car, or the headset, a little Bluetooth headset to a phone, an IP phone system, or a wireless phone, or a smartphone. And so there are your devices. We could drill down and just click on the 400-watt dimmer real quick. Just click on that puppy. And now you can double click on it, and you can control it from there. You're on the right track, Joe. You're on the right track. You can control it from the previous page, or you can go in here and set up the actual system. Give it a device alias, which is really a name. If it's tying into other systems, give it a device number, and make sure it's got a unit number. If it's tying into an Omni system, enable it. And down at the very bottom, this is, and we're not going to go much deeper than this, but this is where you see the power of the system. Here's where you can go in and configure a min-max level, okay? A default soft on rate, default soft off rate. I highly advise for ease of what's the best word I can use? For ease of learning, I would highly advise you all that are online this morning to go on to the Leviton web portal and download the software. Go download the software. Later on, if you want to connect with the Worthington folks, they can actually guide you to. We have a special dealer portal that they can go on and look at little YouTube videos. I know that Joe will be unfortunately posting my ugly face on this YouTube video later on, But you can, we have a lot, basically we have a lot of resources for you, so you can go back and look at this later on or look at my YouTube videos. We can control it right from being in the software itself. We can actually, it's pretty powerful. It's a very simple system. Let's go down to the translator real quick, just real quick. Once I get going, I can't stop. But we can go into the translator here and go and set up. This is what Richie and I did this morning. We went in and we set up the IP network, so we didn't have to worry about we didn't really have to worry about being connected hardwired with an old-fashioned USB cable. And then take this a step further. If I was using a laptop, and this is what I did with one of the contractors recently, on a wireless network, now I can walk the job and test different systems, test different loads within the system. So you can get out of that right now, Joe. Let's go into the scene controller real quick and just double click in there. It's reading the scene controller, and the reason it's doing that, generally speaking, if this was a classroom full of folks online here with me, I would be looking for body language to see if you understood what a scene controller is. We just added this in this morning. So the reason that you saw it listing the device and going looking for it was it hadn't been in the system before. So it went in. We could say, just click into scene triggers just real quick. We can add scene triggers in here. Scene trigger might be, we can configure a scene, but a scene trigger could be one of the wireless key fobs. It could be when I press this button here, activate a scene. It all depends on how you want to configure it. If you want to just get out of there for a second, Joe, close. Yep, perfect. And you'll see we've got a couple of other scenes built already. Exactly. Thank you, Joe. As I say, I'm not going to really go too crazy in here. Let's go over to the relay module real quick. Just to double click in there, and double click anything in the listings just to show the folks what's going on. We can go and look at some info. We could do some setups. We can configure the links. Once you've got links configured, you can then go ahead and test each one of them. You could go ahead, Joe, go into the test and do it, click on and off, and click off. So you could try and play around with your devices, make sure everything's working correctly. We could go and we're not going to go drill too deep. I don't want to spend too much time on it. So you're good. Let's go back over to our presentation. In the presentation, I believe I have a number of sales tips, or I shouldn't say tips, but features that will help you drill down into other tools that we have available for you. So product sales information, this is kind of where I'm going. Why we bring this to market, it's a very simple and easy configurable system. It's retrofittable. That's a key piece that I wanted to point out. And what are the key talking points of this system? Very modular, very easy to add to the system. It can be retrofit with all the wireless devices. It's expandable, and it's a perfect solution for some of the projects that we've seen out there today. We do see, I have to tell you, it is used quite often in the EU condo world, in the Middle East condos, high-end condos. This product tends to be, and here in the US, tends to be quite often used in high-end home automation systems. We do have a number on our website. We have a number of examples. So we've what we call case studies. We can show some of those. If you click on, Joe, one more. Oh, I beg your pardon. I'm in control. Can Omni-bus control loads besides lighting? Of course, we kind of went into that. We can pool pumps. I've seen shades. I've seen motor loads. Is the software free? Yes. What agency approval? We have all the approvals. That's just recently. Marketing and sales material. This is kind of where I was going with some of the key items that we can help you with. We have a very nice brochure. We have product bulletins. We have solution sheets. We have case studies. We have tech sheets. We have demo cases. One other item that's not really on here, we have a full dealer portal, dealer.leviton.com, if you want to write that down, or just connect with us later and we'll actually point you to the URL. It's actually a pretty nice little, yep, that's it. Thank you very much, Joel. You will need to just register and log in. There's no special passwords or anything like that. There's no fees. Omni-bus website is brand new. That's kind of what I was looking at a few minutes ago, which shows you those web real case studies that I mentioned. We offer a really cool solution. It's not outrageously expensive. Contact Worthington if you need to. And my email address is pdonnelly@leviton.com. If you want to get back with me, you're very welcome anytime. I'm always available.